The description of slopes along a surface is useful to help us describe how the surface might appear to our eye or how it might reflect light. A surface will appear shiny if it has gentle slopes. A surface might appear more fuzzy or dulled if it has steeper slopes. The dA parameter tells us something about the slopes on a surface. Let's look at this surface and think about it in terms of the slopes along the way. At this point right here on the surface is a relatively steep slope. At this point on the surface, there's no slope. Now, slope is represented as a delta. So let's look at a point right here going upward, and here's the slope at that point. And if we move over some distance in x, we grow some delta in y. So delta is kind of our slope measure, or at least our slope representation. And the delta, the triangle, is the d in these parameters. So the delta, the slope along the way, is going to be changing. I've got a positive slope here, a zero slope here, and then a negative slope here. And as we work our way along the surface, we're going to see slopes going up and down, and we'll have a wide variety of slopes. We might have some positive slopes, and we might have some negative slopes, and we might have all kinds of different slopes along the way as we work our way along the surface. So at some point we'll have zero slopes. We'll be on the peaks themselves or at the bottom of the valleys. The dA parameter looks at all of these slopes together and doesn't really care if it's up or down. It just says how steep are you at every point. If we look at the steepness or the slope at every point, regardless of up or down, we're going to calculate the average slope, the average amount of tilt. And again, it doesn't matter if it's up or down, it's simply how tilted are we at each point, and that average amount of tilt, or the average slope at every point, is going to be the dA parameter. For example, RdA will look at every point on the roughness profile and calculate the amount of tilt, or the amount of slope at that point, and give us an average of those. Now, this is a parameter that lives often in the same space as RdQ, which is the spread or the standard deviation of the distribution of slopes. So if you're interested in slopes or appearance, RdA or RdQ will be common parameters in that space.